Hello students, this is part 5th of the chapter solutions, and in this part I am going to discuss some numerical problems of two topics, one from concentration of solutions and second from Henry's law. Now let's start this part with some questions. Now first question. The first question is, if benzene in a solution containing 30% by mass in carbon tetrachloride, calculate the mole fraction of benzene. It means benzene is present in carbon tetrachloride where carbon tetrachloride acts as a solvent and in which benzene is present by 30% of its mass. And we have to calculate, for this we have to calculate mole fraction of benzene. Now let's see its solution. According to the question, 30% by mass means mass of benzene to be 30 gram. 30% by mass means mass of benzene should be 30% in total mass of the solution of 100 gram. When total mass of the solution is 100 gram, because it is already given that 30% by mass, it means total mass of the solution should be 100 gram, and in that 100 gram 30 gram is benzene. Now the remaining will be the solvent, and what is solvent? Solvent is carbon tetrachloride. Now, so the mass of carbon tetrachloride will be equal to total mass of the solution, that is 100, minus mass of solute, that is mass of benzene, 30. The mass of carbon tetrachloride will be equal to 70 gram. Now come to the molar mass of benzene. As we all know that formula of benzene is C6H6. 6 number of carbon atom in 6 hydrogen atom. So for this, the molar mass of benzene will be calculated as 78 gram per mole. Now, as we have calculated the molar mass of benzene, and as we know the given mass of benzene, now from this we can easily calculate the number of moles of benzene. Now the number of moles of benzene will be equal to, according to the formula of number of moles, given mass upon molar mass. Given mass upon molar mass. So here given mass of benzene is 30 gram. Given mass of benzene is 30 gram and molar mass of benzene is 78 grams. So the number of moles of benzene will be calculated as 0.3846 mole. Now similarly for molar mass of carbon tetrachloride CCl4, after calculating the atomic mass of each atoms, we have calculated the molar mass of CCl4 carbon tetrachloride, that is 154 gram per mole. Now from molar mass we can easily calculate number of moles of carbon tetrachloride, and here according to the same formula, number of moles equal to given mass divided by molar mass. So given mass of carbon tetrachloride is 70 gram and total molar mass of carbon tetrachloride, as we have calculated here, that is 154. Now number of moles of carbon tetrachloride will be as 0.45 moles. Now the mole fraction of benzene will be equal to number of moles of benzene divided by total number of moles of the solution. Total number of moles of the solution means number of moles of benzene plus number of moles of carbon tetrachloride. Now on putting the values, as we have calculated here, on putting these values we will get the mole fraction of benzene. Here number of moles of benzene, as we have calculated, number of moles of benzene is 0.3846. So here it is 0.3846 divided by number of moles of benzene 0.3846 plus number of moles of carbon tetrachloride 0.4545. Now after solving this On adding these two, we will get 0.839, and on dividing 0.3846 divided by 0.38391, we will get the answer. We will get the mole fraction of benzene, that is 0.4583. So by this method, we can easily calculate the mole fraction of benzene. Now come to the next question. Here, the second question is, if 1.02 gram per ml is the density of 20% aqueous Ki. What is given? Density of 20% aqueous Ki is given, that is 1.202 gram per ml. Now determine the following, and we have to determine three categories. And what are these three? First is molality of potassium iodide, molarity of potassium iodide, and mole fraction of potassium iodide. Let's see the solution. First of all, we will calculate the molar mass of potassium iodide. And what will be the molar mass of potassium iodide? Potassium iodide, atomic mass of potassium is 39. Atomic mass of iodine is 127. Here the from these two, the molar mass of potassium iodide will be 166 gram per mole. Now from this, in the question, the one term is given, that is 20% aqueous Ki. It means 20% aqueous solution of Ki means 20 gram of Ki potassium iodide is present in 100 gram of solution. As we have also discussed in our previous question, and in the same way, here the 20% Ki solution means 20 gram of Ki present in 100 gram of solution. Now, means if Ki is 20 gram, then the water in which the potassium iodide is dissolved, that will be the remaining part, and remaining part is 100 minus the mass of the solute. 100 is the total mass of the solution minus the mass of the solute, that is 20 gram mass of Ki equal to 80 gram. So the mass of water is 80 gram. Now, according to the formula, number of moles of Ki will be equal to given mass of Ki divided by molar mass of Ki. So from here, we can easily calculate the number of moles of Ki. And on putting the values, the number of moles of potassium iodide will be equal to given mass is 20 divided by molar mass, that is 166, equal to, the value is here 0.120. Now, on finding out the number of moles of Ki, the molality of the solution can easily be finding out on applying the formula of molality. Then the molality of the solution will be equal to number of moles of solute divided by mass of solvent in gram multiplied by 1000. Now on putting the values, we will get, on putting the number of moles of Ki, that is 0.120 divided by mass of the solvent. Mass of the solvent is water, and that is in gram, so it means 80, and we have to multiply it by 1000. So from on putting the values, we get the value of molality, and that is 1.5 molar. Now come to the second part. How can we find out the molarity? Since the density of Ki is given in the question, density of Ki is given in the question, and what is the density of Ki? That is 1.20 gram per milliliter. Now from the density of Ki, the volume of the solution can be calculated. From the density, the volume can be calculated. Now volume of 100 gram of solution will be equal to, volume is equal to mass upon density. So volume of 100 gram of solution will be equal to mass of the solution, that is 100, divided by density of the solution, that is given in the question, that is 1.02 gram per milliliter inverse. So from this, the volume will be equal to 83.19 milliliter. Now on applying the formula of molarity, what is the formula of molarity? Molarity, capital M, equal to number of moles of solute divided by volume of solution in ml multiplied by 100. On putting the value number of moles of solute is here Ki, number of moles of Ki, that is 0.120 divided by volume of solution, that is 83.19 multiplied by 1000, and the value of molarity will be 1.44 molar. Now come to the third part of the question, that is mole fraction of Ki. What will be the mole fraction of Ki? How can we find out? For mole fraction we have to find out number of moles. So number of moles of Ki, we have already find out the number of moles of Ki, but the number of moles of solvent and the number of moles of water will be equal to again given mass upon molar mass, and given mass is 80 gram, whereas molar mass of water is 18, equal to 4.44. Now on applying the formula of mole fraction of potassium iodide will be equal to number of moles of potassium iodide divided by number of moles of Ki plus number of moles of water. So on putting the value we will get the answer, and the mole fraction of Ki will be equal to 0.0263. Now come to the third question. Here is the third question. If nitrogen gas is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume that nitrogen exerts a partial pressure of 0.987 bar. Partial pressure of nitrogen as given, that is 0.987 bar. Given that Henry's law constant for nitrogen at 293 Kelvin is 76.48 kilobar. Now let's say the solution. Since the solubility of a gas is related to mole fraction in aqueous solution, this is according to Henry's law. Now the mole fraction of the gas in solution is calculated by applying Henry's law. Thus, the mole fraction of nitrogen, since Henry's law is partial pressure of the gas, is equal to Henry's law constant multiplied by mole fraction. So, mole fraction of nitrogen will be equal to pressure of nitrogen divided by Henry's law constant. This is from Henry's law. Now, on putting the values, partial pressure of gas is given, that is 9.87 bar divided by value of kH, Henry's law constant, that is 76.48 kilobar. On converting this kilobar into bar, we will multiply this term with 10 to the power 3, and on multiplying with 10 to the power 3 we will get 76480 bar. Now after this, the value of solubility or value of mole fraction of nitrogen will be come out as 1.29 into 10 to the power minus 5. Now since it is given in the question that as 1 liter of water, that nitrogen gas is dissolved in 1 liter of water. In 1 liter of water contains 55.5 mole of water. 1 liter of water has 55.5 mole of water. It means if N represents the number of moles of nitrogen in the solution, then the mole fraction of nitrogen, will, according to the formula, will be equal to number of moles of nitrogen divided by number of moles of the solution, means number of moles of nitrogen plus number of moles of water, and in 1 liter number of moles of water is 55.5, means 1000 upon 18, we will get 55.5 given mass upon molar mass. Now from this, on putting the values of mole fraction and number of moles of water, what we will get? We will get this equation, this type of equation. Now on solving the equation, since the number of moles of nitrogen in denominator can be neglected, since it is very less than 55.5. it can be neglected since it is very less than 55.5, which is the number of moles of water. So we can neglect the number of moles of nitrogen in the denominator. Now as we neglect the number of moles in denominator, what will we get? We will get the number of moles of nitrogen will be equal to 1.29 into 10 to the power minus 5 multiplied by 55.5 moles. This will get neglected. So N will be equal to 1.29 into 55.5. Now the value comes, the number of moles of nitrogen comes equal to 7.16 into 10 to the power minus 4 moles in millimoles. But we have to find out the number of moles in millimoles. The unit should be in millimole. For converting the mole into millimole, we will just multiply the answer with 10 to the power 3 or with 1000. Then it can be converted into millimoles, and after multiplying it, the value comes as 0.716 millimole. This is the answer. Now come to the fourth question. Here is question 4. Sulfuric acid H2S is a toxic gas with rotten egg-like smell, is used for the qualitative analysis. If the solubility of H2S in water at STP is 0.195 molar, calculate Henry's law constant. Here we have to calculate the value of KH, Henry's law constant, and the solubility of H2S in water at STP is given. Now let's see the solution. 0.195 molar solution means 0.195 moles of sulfuric acid dissolved in 1 kilogram water. This is molar solution, and molar solution means 0.195 moles of sulfuric acid dissolved in 1 kg of water. Now the given, since in the question one condition is given, and that condition is at STP. It means at STP the pressure is 0.987 bar. Now moles of H2S is given. Moles of H2S is 0.195. According to the question, the moles of H2S are given, and that is equal to 0.195. Now according to the formula of number of moles of water will be equal to given mass upon molar mass. So given mass of water, as we are talking in STP, so given mass of water is 1000 divided by 18, that is 55.55. Now from the formula of mole fraction of H2S, mole fraction of sulfuric acid will be equal to number of moles of sulfuric acid divided by total number of moles of the solution, means number of moles of sulfuric acid plus number of moles of water. So on putting the values, we will get the number of moles of the mole fraction of H2S, that is number of moles of H2S is 0.195 divided by 0.195 plus number of moles of water. So here the mole fraction of H2S is 0.0035. Now according to the Henry's law, as we have to find out the value of KH, Henry's law constant, and here we have calculated the mole fraction and pressure is already given. So according to the Henry's law, as pressure is equal to Henry's law constant into mole fraction. Now from this, the Henry's law constant will be equal to pressure upon mole fraction. Now on putting the value of pressure and mole fraction, we will get the value of Henry's law constant, and here the value of pressure is 0.987 bar divided by mole fraction that we have calculated here, that is 0.0035, and on putting the value of KH is equal to 28 bar. So this is the answer, and this is the value of Henry's law constant for H2S case. Now come to the next question. Here is question 5. Henry's law constant for CO2 in water is 1.67 into 10 to the power 8 Pascal. It means value of KH is given here at 298 Kelvin. Calculate the quantity of carbon dioxide in 500 ml of soda water when packed under 2.5 atmosphere carbon dioxide pressure at 298 Kelvin. It means pressure is also given in the question. Now let's see the solution. The value of KH is given, that is 1.67 into 10 to the power 8 Pascal. Pressure is given in atmosphere, that is 2.5 atmosphere, and here we have to convert atmospheric pressure into the pressure in Pascal unit, and to convert atmosphere into Pascal unit we have to multiply the atmospheric unit into 10 to the power 5. So on converting atmospheric unit of pressure into Pascal unit, the value of pressure will be equal to 2.5 into 10 to the power 5 Pascal. Now according to Henry's law, pressure equal to Henry's law constant into mole fraction or solubility. So from here, the solubility of carbon dioxide will be equal to pressure upon Henry's law constant. Now on putting the values of pressure and Henry's law constant, we will get the solubility of carbon dioxide, that is pressure of carbon dioxide is 2.5 into 10 to the power 5 Pascal divided by 1.7 into 10 to the power 8 Pascal, that is Henry's law. So from here the solubility of carbon dioxide will be 1.49 into 10 to the power minus 3. Now number of moles of water, since in the question it is given that 500 ml of water, 500 ml of soda water is there. So number of moles of water according to the question will be 500 upon molar mass of water, that will be equal to 27.77. Number of moles of water is 27.77. Now mole fraction of carbon dioxide, according to the formula of mole fraction, number of moles of carbon dioxide divided by number of moles of carbon dioxide plus number of moles of water. On putting the value of number of moles of water and mole fraction of carbon dioxide, we will get an equation, and this is the equation in which the number of moles of carbon dioxide, that is N of CO2, and number of moles of water, that is 27.77, and we have mole fraction of CO2 that we have calculated earlier, that is 1.49 into 10 to the power minus 3. Now on rearranging the equation, by rearranging the equation and multiplying the equation terms, we can find out the value of number of moles of carbon dioxide. On dividing these two terms, we can find out the value of carbon dioxide, number of moles of carbon dioxide, that will be 0.088. Number of moles of carbon dioxide are 0.0388. Now as the number of moles are already calculated, now the amount of carbon dioxide dissolved, now the amount will be equal to number of moles into molar mass. Since according to the formula, what is number of moles? Number of moles equal to amount divided by molar mass. So the amount of carbon dioxide dissolved will be equal to number of mole into molar mass. Now on putting the value, we will get the amount of carbon dioxide dissolved, that is 1.707 gram. This is the answer. This is all about today, and these are the questions related to the topics as we have discussed in our previous videos. So now you have to solve some more questions, and for those questions I have some assignment for you, I have some questions for you. So let's see those questions and try to solve those questions. So here are the questions which we have to do for your home assignment. So these are 5 questions which you have to do by your own. Try to solve these questions. So that's all for today. Thank you.